So this is my project for assignment 3 for the Advanced Robotics module at Middlesex University. The task for this was to create some sort of interface which allowed users to control a universal robot in a simplified way, so that they can select an object on a table and the robot will approach the object and pick it up. Now the robot, unfortunately, we don't have access to a gripper, working gripper, so currently the robot just sort of approaches the object, indicating this is the point at which the gripper would be activated. And then a user can decide if they want to move away from that object or move to another object. In the scenario where we did have a gripper, there would be added functionality so that a user could click somewhere else to on the table to place the object. Now, in order to start running this program, I have created a launch file, which is a combination of the 2 or 3 processes you'd normally have to complete in order to get this up and running. And you can still do those separately. This is in no way different to those, it's just combined them. So it is spawning the robot into Gazebo with the table and the cubes, along with the joint state publishers and the move it planner. Now, the other way we can run this launch file, the other way is to launch them incrementally. So you launch in the table with the camera and then the robot and then the cubes if your processing power is low. If it's not, then you can just run the assignment3.launch file here I've made. And it does take a second to load up depending on the speed of your computer. And that will just load the robot into Gazebo, or load paused. I've done that because the cubes fall through the table otherwise, due to the fact that the way ROS loads these files in, it isn't actually linear. So sometimes the cubes can load first. And in order to stop that, I've just made sure the simulation is paused on load. As you can see, they're all in the cubes are in the air. Just zoom in here. I've got the camera up here and press play. So in order to load main part of this assignment, which is my script, which combines the move it commander to control the robot and a camera feed, which is given to us through this simulated camera in the Gazebo, you can see there. It's converted to OpenCV format using the bridge tool, and then we run some image analysis on the video stream. Those are coupled into one file, so we have the commander and the image analysis in one file. In order to run that, you can move into the scripts folder of this package I've created, and you will find a folder called Move It Commander. It's Move It Commander demo here at the moment, but the name will change. So we can just simply run that file. It's using Python 2. And we'll get this failed to import, but it's not a problem. On load, it moves the robot to a home position, a defined home position in the code. And whoops, I forgot to remove this from the code here. Oh no. 1 second. It's just doing some tests to save some images for the small essay I've written. So this is the interface we're given as a user. You can see the center point of the robot base there and contours surrounding the top faces of the objects we can see. What's nice about the interface here is a user can actually double click on the contours and the robot will plan and attempt to execute that plan to move to the object. And as you can see here on the left, it's exactly what it's done. It's using a waypoint system, Cartesian system, so it attempts to find, occasionally not, but a straight line path to a designated spot. Now those designated spots are always a few centimeters above the object first, and then the robot will move down, and that's a safety implementation there so that it doesn't sweep across the table or knock anything over. As we can see, we do have the controller does fail sometimes, the planner does fail. This is something I haven't been able to fix, but it's something to do with the move it commander and restrictions of the documentation and things with the move it commander here, which also means there isn't any error handling for these events where, for example, we have a solution found but the controller failed. I find that often double clicking, it just crashed. I haven't had that happen before. I find that double clicking the contour a few times will allow the commander to find a new plan. Now, in the scenario where there was some error handling, in that I could determine in this script whether the planner found a path, I would ensure that if the planner couldn't find a path, it would keep on attempting until X amount. So found an object there. The robot should, moves to the next object on click. Now in the event in which the object is out of reach, in this scenario, the robot actually attempts to go there with this Cartesian path planning, but it only completes about 40%. Here, 42% of the requested trajectory. Again, due to error handling, I cannot catch this and tell it not to bother going there if it can't complete the trajectory, or tell the user the robot cannot try this or do this. But this is my best attempt, and if you double click the background, the table, the robot will return to home position as well. The contour detection works by, actually, as you saw, the multiple windows show up at the beginning of this stream. It works by combining several masks, the red mask, blue and pink mask of these objects. We use a upper and lower bound of the HSV value of those objects, the top faces of those objects, and that upper and lower bound is kind of randomly chosen in that OpenCV gave a recommendation. And that's completed with an individual function here for each color of object. And if we added objects of different colors, we would indeed have to add another mask here. A nice improvement would be to move these values out into a JSON file to decouple this sort of static data from the program, and also one possibility for improvement as well is to decouple the commander from the image program in some way. That can be done by publishing the coordinates when the user clicks to a topic and then subscribing to that topic with the commander. But due to the interface I've created, there are direct links between those two programs that required me to have access to shared variables and things like that from within the same program. So that was why this is all in one file. And the double clicking is all handled through OpenCV using event handlers for the left button click, and in order to detect if that's within a contour, it's using a point polygon test, which checks if a coordinate or a vector xy is in or on a contour. If you wanted to remove that check so that when you double clicked anywhere on the screen, the robot would attempt to go there, you can remove this check. Here. So we just say if I've button click, then we just send the coordinates of the x and y to the UR5 object function, move to object function, which just takes an x and y tuple. Sorry, no, this is running to send coordinates, and then here you would ignore that. You would just call ur5.goToObject, and then just call it with the x and y values. And then if I run this again, this should allow me to just move the robot to anywhere on the screen, as it's not checking that the place I've clicked is within a contour. This is possible because the programs are coupled. So I've just clicked there, and there is a set Z height for all of these positions. So interestingly, that is the position the robot has decided to go on. Okay, but this is how you would do that. Thank you for watching, and yeah, this is my hand in for assignment 3.